Welcome to the deep dive. Ever wonder how computers figure out if two things said in different languages actually contradict each other?
Yeah, like total opposites.
Exactly. Today, we're diving into some really interesting research. It kind of cracks open how the latest AI tries to tackle this whole puzzle. We're using some cutting-edge tech here.
Hmm.
Our mission, really, is to see which methods came out on top and maybe understand a bit about why.
Right. And we're looking at a specific paper today. It details experiments on a kaggle data set called Contradictory, my dear Watson. Pretty clever name.
Ah, yeah.
It basically throws like over 12,000 pairs of sentences at these computer models.
12,000. Wow.
Yeah, and in more than 15 languages, the models have to decide.
Hmm.
Do they mean the same thing that's entailment or something unrelated, which is neutral?
Or the opposite contradiction.
Precisely. Contradiction. That's the core task.
Okay, so why is this important? I mean, why is teaching a computer to spot these contradictions across languages, why is that such a big deal?
Well, think about real-world stuff, like spotting misinformation or fake news that spreads across different language communities.
Well, okay. That makes sense.
Or even, making chatbots better.
Right.
Imagine a customer service bot dealing with multiple languages. It needs to understand the actual issue, not get confused by phrasing.
Right, avoiding misunderstanding. So this research is really about building smarter AI that gets those nuances.
Exactly. For tools we might actually use every day.
The paper mentions these transformer models. You hear about BERT, XLM, Roberta. Can you give us the quick version? What are they?
Sure. Think of them as super advanced language readers. They don't just see words in isolation. They understand the context, how words relate in a sentence.
Okay.
And the models mentioned, like XLM Roberta or Roberta itself, they're generally more powerful, more refined versions than, say, the earlier BERT models.
And some are multilingual, others specific.
Yeah, that's key. Models like XLM Roberta are built to handle many languages at once. Others, like Roberta, are often fine-tuned really well for just one, like English in this case. The paper even touches on the progress from BERT up to things like XLMR and DeBerta.
Got it. So the researchers didn't just use one model, they compared different strategies, right? Four main approaches.
That's right, 4 key experiments. First, they set a baseline with a pretty standard multilingual BERT model, like a starter pack.
Okay, the basic board.
Then they went bigger, using a single, more advanced XLM Roberta model trained on all the languages together.
One model to rule them all kind of thing?
Sort of, yeah. The third approach was interesting. They split the data. They used Roberta, the English specialist, just for the English sentence pairs,
Uh-huh.
and then used the multilingual XLM Roberta for all the other languages.
Ah, a divide and conquer strategy.
Exactly. And finally, they tried that same split approach, but they added a twist. They augmented the English training data with synonyms, basically adding more similar words.
Okay, trying to give the English model more examples. And what worked best? What was the winning approach?
So the best result came from that split approach. Using Roberta for English and XLM Roberta for the rest, that one hit a score of 0.67564.
Okay, so specializing helped. What about adding the synonyms? Did that boost the English part?
That's the really surprising bit. No, it didn't. In fact, adding synonyms made the score slightly worse. It dropped to 0.67237.
Worse. How come? You'd think more data helps.
Well, the researchers guessed it might be due to, like, semantic drift. Swapping in a synonym might subtly change the meaning, or maybe the synonym just didn't fit the specific context of the sentence. Context seems key.
Huh. So just jamming in more words isn't always the answer. What about that single XLM Roberta model trained on everything, the simpler approach?
That actually did pretty well. It was a strong second, scoring 0.66852. And the paper points out, it is simpler to implement, just one model to manage.
Easier setup, yeah. And the basic BERT.
That performed the weakest, score of 0.62829. It really highlights how much progress has been made with these newer architectures like XLMR and Roberta.
Right. The paper also mentions TPUs. Just quickly, what role did they play?
TPUs, tensor processing units. Basically, they're specialized hardware accelerators, like super fast chips designed by Google for AI tasks. They just let the researchers train these massive models way faster.
So efficiency. Makes sense with models this big.
Definitely crucial for these kinds of experiments.
Okay, so if we boil it down, the main takeaway seems to be when you're dealing with the nitty-gritty of contradiction across languages, tailoring models to specific languages like they did with English Roberta can actually be more effective than just using one general multilingual model.
That seems to be the conclusion, yeah. Those big multilingual models are incredibly versatile, very useful, but they might sometimes gloss over the really fine linguistic details that a specialized model can pick up.
Right, the subtleties.
Exactly.
That finding about the synonyms not helping, maybe even hurting, that's quite counterintuitive.
It really is. It underscores that language understanding isn't just about vocabulary lists. It's so deeply tied to context, to how words are actually used.
Makes you think about how we improve data augmentation then. Need smarter ways than just word swapping.
Absolutely. Techniques that are maybe more context aware in the future.
Well, this has been a fascinating deep dive. It really shows that building AI that, truly gets language across cultures. It's still a complex challenge, but we're making progress. Thanks for breaking down that paper for us.
My pleasure. It was an interesting one.
And for everyone listening, maybe think about this next time you use a translation app or a search engine. How do these findings influence the tools trying to understand you better no matter the language? It's all about pushing towards that more nuanced understanding.